In this video, we will talk about the architecture, capabilities, thinking controls, and inference requirements of the Qwen3.8-27 billion parameter model. I'm Mehrdad, and let's begin with the architecture. Start with the decoder. Its 64 layers form 16 identical groups. Each group contains 3 gated DeltaNet layers, followed by 1 full attention layer. That gives 48 linear mixers and 16 full attention layers. Gated DeltaNet carries prior information in a fixed-size recurrent state. Only the full attention layers build a sequence-growing key-value cache. Every mixer is followed by a dense feed-forward network with no expert router or sparse expert bank. A separate vision encoder maps image and video features into the language model. The checkpoint also includes a multi-token prediction head for speculative decoding. This is the same decoder graph as the Qwen3.8-27 billion parameter model. The 3.8 change is post-training, not a new block. If this series is useful, like the video and subscribe for more model architecture lessons. Thinking is enabled by default. The model generates reasoning before its final answer, but you can switch to direct response without changing the checkpoint. When thinking stays on, reasoning effort can be extra high, medium, or low. Extra high is the default. Lower effort reduces reasoning within one turn, but may require more turns or retries. Preserved thinking is a separate control. It keeps earlier reasoning blocks in the conversation and can improve cache reuse. Thinking tokens still consume context and generation time. For tool calls and reasoning output, the serving engine uses separate coder and reasoning parsers. Inference memory includes weights, key-value cache, recurrent state, runtime workspaces, and vision activations. Published 4-bit builds use roughly 17 to 19 gigabytes for weights, so 24 gigabytes is the practical local class. 16 gigabytes leaves little room for cache and runtime state. FP8 fits the 48 gigabyte class, while bfloat16 moves into the 80 gigabyte class. The native context limit is 262,000 tokens, but usable length depends on the memory left after loading the model. Unsloth reports about 134 output tokens per second at batch 1 on a B200 with NVFP4. Alibaba's local guide cites a Qwen3.8-27 billion parameter proxy near 30 tokens per second on an RTX 3090 at 4-bit. These figures describe different engines and hardware, so they are not direct speed comparisons. Qwen3.8 names 3 different deployments. The 27 billion parameter model is the Apache-licensed dense vision language checkpoint sized for quantized single GPUs. The open 2.4 trillion parameter checkpoint is a text-only mixture of experts with about 95 billion active parameters. Its thinking mode stays on. It uses the custom max license, and the NVFP4 recipe requires 8 B300 accelerators. Qwen3.8 Max is the hosted model. It provides multimodal input, optional thinking, integrated tools, and 1 million tokens of default context. The downloadable 2.4 trillion parameter checkpoint and hosted Max are therefore not the same deployment. These benchmarks test agentic terminal work, software engineering, code generation, and computer use. Qwen reports improvement across all 4 task groups compared with 3.6. The strongest gain appears in computer use, with broader gains in coding and agent tasks. This pattern suggests a meaningful quality improvement in practical tool-using workflows. However, these are first-party results under Qwen's evaluation setup, not an independent ranking against other models. Compare the alternatives by structure and deployment before looking at scores. The Qwen3.8-27 billion parameter model is the closest architectural control. Muse Glimmer 30B and Gemma 431B are dense models with sliding window and periodic global attention rather than gated DeltaNet. Mistral divides its 24 billion parameter line across general, reasoning, and software engineering checkpoints. Kimi K2.6 activates about 32 billion parameters per token, but stores 1 trillion and requires cluster deployment. These models do not share one inference profile, and their vendor evaluations do not provide one independent ranking. That is the Qwen 3.827 billion parameter path. Architecture, thinking controls, inference, then the family and reported capabilities. If you want the next model architecture lesson, subscribe and turn on notifications. Thanks for watching.